All right, so we have some basic integration rules. Some of them you have worked with more recently than others. I think I've got the right one off. Maybe not. Let's try it again. I don't know. You can tell me. All right, so the integration worksheet, that's what we just talked about. So you should make sure you've memorized through what we had as our number 18 on that integration worksheet. You should remember U substitution. You will see U substitution used in this section. Keep in mind you have some arc trig rules. Those are ones that you probably didn't see used as frequently as others. Okay. In fact, I remember when we were working on the U substitution, we would see some of those arc trig rules inside of U substitution. So working to identify those more quickly. Remember simple algebraic simplification. So some of those things are exponent stuff like we've just talked about, right? Other things might be remembering that when you have something like 4x plus 1 over 5x, that you can write this as 4x over 5x plus 1 over 5x. That might be a useful feature. So remembering some simple algebra kind of things that where you can separate fractions. You can separate radicals sometimes as well. For instance, if you had the square root of 52x, you can write that as a square root of 52 square root of x if that were helpful. You can't do that with addition underneath the radical, but you could do it with multiplication or division. That kind of stuff is what the algebraic simplification. Completing the square, which was absolutely your favorite thing to do when we worked with arc trig functions, right? Maybe not, but it's still helpful, and it's something you guys know how to do. So it sometimes catches us off guard, but it is a technique that's helpful. Long division. Who loved that one? When do you use long division? Do you remember? I mean, this says improper fractions. What does that mean in terms of the algebra we've been doing? When were we using long division? We had it with polynomials. What specifically had to be true about the polynomials? Had to do with the exponents. Do you remember? Right. The numerator's exponent, largest exponent, needs to be larger than the denominator's largest exponent. That's when we would see that happen. Or the same. It could be the same, right, Erica? So they could both have, for instance, an x cubed in them. So when that simplifies, we actually get usually a piece that's a whole number piece or a whole value piece. Maybe it has some variables in it, and you've got a remainder that's still left over that denominator. So that's when we were using long division, was when we saw the exponent in the numerator at least as big as or bigger than the exponent in the denominator. And then trig identities. Who remembers their trig identities? Maybe not. There is a handout out online on our website, our Moodle Room site, with trig identities. So if you don't remember some of those, you can go and you can grab that. So I don't think I printed them off, but these are some of them. And this is what you'll see out online. So make a note to yourself. If you've already printed off, that's awesome. If you haven't, oh, I see some of them. Jana's got one. So this is what it looks like, right? This came straight out of when some of you took trig with me. You've seen this actual sheet before with a header change. And so you've got your quotient identities, reciprocal identities, Pythagorean identities, even odd identities. Those are the ones that are going to be the most helpful for us, are the first four of these sets, okay? We're going to get into and explore some more of the bottom ones later as we move through Chapter 8. But the ones at the top are the ones that you're going to find the most use for right now. So if you see something, in fact, you saw, for those of you who decided to work on the last test with sines and cosines instead of changing it into tangent on that problem, there was a Pythagorean identity in that problem. You ended up getting a sine squared plus cosine squared at one point, and recognizing that that was equal to 1 was necessary had you chosen to go that route. Again, there was a quotient identity if not, because you had to recognize, or you could have recognized, that sine over cosine is equal to tangent. So those are helpful identities to remember as you're working with things with trig. Any questions on this? All right.